So can people see my blue PowerPoint?
Looks good.
Oh, good. Okay, so that was seamless. Let me put this in slideshow mode. Current slide, there we go. So this is an idea I had with my frustration in doing so many faint targets now that I feel like there's events all over the place. And so let me just go ahead and get started here. So the Gaia data release 3 has now got so many accurate stars and asteroid orbits that my OW has gone from, 2 or 3 events a month to like 2 or 3 events a day. And so I'm over tempted. Now, if you've got a really bright star, then you don't really need to worry about this new technique. Look at those timing accuracies. Alchemine, this was actually an interesting one. I noticed the RUWE was poor, and yet it was a really bright star, and I didn't really want to drive 150 miles and not know where, not know whether I could get it. So I said, why don't I just try it from home? I mean, if the accuracy is a lot worse than they expect, then I got a 50-50 chance it may shift up here to Santa Cruz. And it did. So anyway, that's just a shot at a very beautiful light curve. But the problem now is there are so many tough events out there that they outnumber the easy events by 10 to 1. And my life, frankly, I spend most of my time thinking about presenting presentations and doing research on climate change, which, as you know, is stressful and frankly, nobody wants to hear about it. So I am even more tempted than I ever was before for these little astro getaways to grab a scope and go out and get an asteroid occultation, even if it just takes me away from all that for a few hours. So the problem is that my auditors are learning to sigh at when they see a Richard Nolthenius anywhere in their emails, like, we got to try and dig some Nolthenius thing out of the noise again. So I'm trying to think, well, how could we make these difficult events a little easier? And it occurred to me that, well, there's this great capability inside PyMovie already for making making finders, what they're called. And you've got additional levers to work with there. And if you could just automate that, then that could actually make things easier. And I'll show you an example. Okay, if you've got a bright moon nearby, which I've had several events lately like that, or deep twilight, I've had events like that lately. Or even if you're just in a city and you can't get out, then you're gonna have bright skies. And if you have relatively faint targets, pulling them out is tough. So last weekend's occultation by Quawar is a good example. So this is me up at UC Santa Cruz over Meadow. And the target, as some of you may know or remember, was only 10 degrees above the moon. And the moon was 90%. And the target was 15.3 magnitude. So normally I wouldn't even think of spending time on something like that, but it was Quawar, and I thought, well, what the heck? Let's see what I can do. And I thought, well, later I could try and make finders, and given how long the event is, a full minute, that it could be possible to see that there was really an event, even if the point-to-point scatter in the actual data was so random that PyMovie might say, no, I don't think you've got anything significant here. So I said, okay, I'm going to do this. Yeah, so there we talked about that. Sky brightness and big moons is really the big place for trying to do something like this, I've decided. So the advantage of a finder is that instead of, well, when you increase the integration on your camera, then you're making all the pixels just brighter. It might not be long before, especially in a bright sky, you're hitting saturation. You don't really improve your signal to noise that much, at least if the sky is bright. But what you're doing with the finder is you're averaging. So these random up and down brightnesses within sky pixels can get averaged out, whereas the pixels where your star is are always going to be high, at least as long as the star is there. And so it can improve the visibility. You can also do these finders and you can space them in such a way that they overlap so that you can retain some of the inherent time resolution, even if you're actually doing a finder over a significant length of time. So PyMovie, if it were to try and incorporate this, would need a little bit of programming, but hopefully not a whole lot, because the capability for doing background and range and for making finders is already there. What you need is the ability to turn the finders into a sequence and turn it into a video. So FFmpeg, I guess, is the engine for so many video programs, and I know that it can do that. I tried today to do that so I could show you a video, but I ultimately failed. So I'm going to have to show you a whole sequence of slides of Quawar. I'll do that soon. Now, the photometry will clearly be compromised by this, this idea. When you're just moving your background and range to wherever you need to make the star optimally visible, then you're going to lose accuracy and baselining for your brightnesses. So it's the utility of this is mostly for asteroid occultations, not for things like planets or moons with atmospheres where you're trying to diagnose the atmosphere. But most of what we do is that, just asteroid occultations or things where there's no atmosphere involved and you just want to know whether it disappeared or not. So the Quawar event is a good example, and it happened recently, and I've been working on it anyway because I have to turn in my data, which I did last night, to Lucky Star. So the target on my C2A chart isn't even visible. Even when I cranked up the limiting magnitude to 15.5, it did not show that star. But I think you can tell with the green light curve here that it's mostly a little bit above sky. Now you might look at that and say, well, you're not really going to be able to get anything out of that. But the occultation is there, it's right there. These are a couple of tracking stars. I always use 2 tracking stars because I've got an Altazimuth telescope and I need to correct for image rotation. So here is PyMovie. What I did is I adjusted the settings so that the sky was as bright as I felt I could get away with, a compromise between high integration so I could detect the star, but not so bright that it was lost. That turned out to be at 16x, so that's half-second time resolution. But for an event that was supposed to last 40 or 50 seconds, then that's still usable or worth doing. So the occultation is in here. And you can stand back and look at that and say, well, maybe, I think there's something there. And indeed, when I ran it through PyMovie and then Pyote, then I did get an event and it did pass the 0 false positive. Not enormously, but frankly, I was amazed that it even did that because, I mean, again, this is an 8-inch telescope at 31 degrees altitude right above the moon, 15.3. I've never attempted anything like that. So they might say, well, Rick, that's tough to beat. Are you really going to be able to do better than that with this new idea that you've got? Well, I wanted to find out. So here is a 3-second finder. And I've adjusted the background and the range so that the sky is sort of optimal. I should mention I've got another pathology with my camera, and that is I get these vertical noise bars, and I've tried to diagnose exactly where it's coming from. I pulled everything out except the camera, Kirk Bender has helped go back and forth with different equipment. I've loaned a Wattec to Kurt so that he could join all this fun. And he's the one who ended up with a good camera. And I've got a worse camera. Anyway, just another challenge. But look, see that little thing there? That's the target. So you want to remember where that is. It's right between this 12th and 13th magnitude star pair, a little bit below the line that joins them, and a skosh closer to the upper star. So that's what's to remember. So there we're zoomed in on the pyote reduction, and you can see how noisy it is. The predicted duration of the event, if the occult watcher prediction was perfect, and our location given where it was, and the 63-second predicted duration, if that were correct, then our duration should have been 44 seconds. So I got 33 seconds. I don't know. I know there was somebody who got a 60-second event. Kirk also got a detectable one. I'll show you his data in a second. But I don't know if anybody got it well enough that we can really tell whether there was a north or south shift. If anybody knows, I'd be very curious to know before we end here. This is Kirk Bender's data, and you can see he's got a little bit better camera and got a little bit more signal, I think, compared to mine. It's less noisy. It's just a little bit more compact. He got a 40-second interval for the event. I got 33 seconds, and we were only 3 miles apart. So they should have been about the same. So the actual interval, I don't know, 37 seconds or so out of a predicted 44. Sounds reasonable. And again, look at the accuracies here. So 2 sigma accuracy is 8 seconds for each of the D and the R. Okay, so now I'm going to just go through a sequence of these slides, and you can see zoomed in, and again, look at where the target is. And now these are 2-second integrations. So this is doing 4 separate Wattec integrations. So we did half-second integrations, and I'm going to do 4 of those together. So that's a 2-second finder that you're seeing here. Okay, so we're just going to go 2 seconds at a time, and you can still see the target here, barely. Still there, barely, maybe. Little blur there. I think that's it. Still there. Still there. Still there. A little better there. Focus came in and out clearly, but it was actually pretty good conditions. Still there. Yeah, maybe. Kind of blurry. Still there. 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 And so from frame to frame, you're seeing it's still there. The predicted time of the disappearance would be about 31:22, 31:23, 24, something like that. So we're getting pretty close to it. We're at 6 hours, 31 minutes, 19 seconds. So we're about 3 seconds away from the event. Not obvious whether it's still here. The position should be right about where my arrow is. It might already be gone. And I would say it's definitely gone now. And it stays gone. In my rush, I sometimes cropped it in a different place. Still gone. Still gone. Is that it? Maybe. But it's probably just a random wiggle in sky noise. Now this is in a bright vertical bar of noise, which my camera seems to be prone to, so it's really not going to be able to tell you much. But here, this is a good one, and it's definitely not there. Not there. Not there. That's the right position. Is it coming back? Nah. No. So there's something here. This is not quite the right position. Should be higher up. Should be right there. So now it's definitely back. It's in the right position. And the next is even more obvious. So, and there's many more that I could have stacked together, but I ran out of time. So the thing that I think is important to note now is that the eye and the brain have a way of looking at everything, not just your little aperture that you put PyMovie on, and get an idea of significance. And if there were a way to somehow incorporate that in the software, I think that would also be an improvement. Might be asking a lot. I don't know. Anyway, that's my last slide, except for this one. I do think that if we could somehow automate flat fielding and dark subtraction, I haven't checked, but I didn't see it in any of the menus in PyMovie. If it's there, somebody let me know. Okay, so that's what I got.
Say, Rick, this is Bob Anderson.
Hi, Bob.
I see that you know that there were vertical median filters available, and that did not help you?
Well, I don't know if those are applied to finders. They do. I do notice they help, and I see them when I'm doing an analysis. So when I click the analysis button, I do see that they've been put into place. But when I do a finder, I don't. My impression is that that's not used.
No, that's a good point. My other comment is I think that this technique is available in Tangra. I believe that Tangra has this ability to integrate a selected number of frames in, as you put it, a cadence. I just wanted to point that out, and it's actually not that difficult, I think, to add that as a feature if in fact it has value. I was aware of this feature in Tangra, but I had never seen it used in anger effectively, and so I did not try to add that to the Finder feature of PyMovie. There are a couple of people here who are experts on Tangra, and they can chime in, and I think I probably have some things to learn about that.
Yeah, I use Tangra to get good photometry of the Hayabusa reentry. I got on the NASA ground team in Australia about, what, 12 years ago now. But that's the last time I've used it, and I don't have it on any of my current computers, and maybe I should.
Well, Dave Harold is listening in, and I think Dave Galt and their Tangra users, they can weigh in on this item.
Yeah, I've already got a welcome from one of them who said, yeah, send us your data and we'll be happy to play with it.
Yep. A couple of comments from my perspective. The first thing I need to put on the table is when we set up the business of reporting astrometry, a critical part of that process is that we would only report astrometry where we were in effect certain of the fact of an occultation. People need to understand that our astrometry is 10 to 100 times more accurate than typical astrometry. And in orbit solutions, our astrometry is given much higher weight than traditional astrometry. And that means that if we report an occultation astrometry, which is wrong, it has the seriously negative effect of degrading the orbit, which will make it more difficult to observe future occultations and everything else. So the issue of certainty of an occultation is a very important issue for all that we do. If we're in a position to say, I think I got an occultation, there is no way we should be reporting astrometry from that, because it doesn't have the right level of certainty. On the noise issue.
Yeah, so I wondered if it were possible to just attach a weight to each of our submitted observations.
Our submitted observations has various uncertainties associated with it. Weighting, the basic thing is that our observations as a whole are weighted, given great weight, but the associated uncertainties are taken into account with that as well. But underlying that whole process is the fact of certainty in the fact that we saw an occultation. If it's a case of, I think I saw an occultation, there's no way that you can use that to reliably improve an orbit, because did you see it or didn't you not? It's like trying to measure a CCD image and say, well, is the object there or not? And trying to rely upon it. I mean, the problem is the difference between the information where you say, I know the asteroid was in this position, versus I think I recorded an occultation and this is consistent with my belief, and yes, I can say I saw the occultation, but it's not, my observation is not independent enough to say that I actually did see it, and here is the position that can be derived from it. It's a very important issue, and it's fundamental to the high reputation that we have with the astrometry that we derive. I mean, this is an important issue for the Horizons people, which I've spent hours and hours discussing these types of issues with, and with the Minor Planet Center. I mean, with our astrometry, there's a thing called, I forget the acronym. There was standards set up a couple of years ago by the IAU for reporting astrometry, new standard. And they've actually had to amend that to make use of the data that we get from the asteroidal occultations. I can't overemphasize the importance of certainty of an occultation to our astrometry, as distinct from, I think I saw it.
Well, I think there's a middle ground there that could be usefully employed. So I know if I were wanting to observe a future occultation and there was a 95% chance that it had been observed, that there was a definite occultation maybe 2 or 3 other times, but they weren't reported and they weren't used, and yet they could have improved the prediction and gotten more people out to try the new one. I would think that would be a gain. There was very little loss. If you're talking about a space mission, well, yeah, but even there, I think some kind of accuracy put on the astrometry. Clearly, if you've got a definite occultation, but you've only got 1 chord, you're also going to be quite a bit less certain than if you have 2 chords versus 3 or 4. So to have it binary, certain or uncertain, or a guess or a emotional reaction, seems too binary to me. But anyway, that's my feeling.
Can I say single chord events, the uncertainty in the position of the asteroid is fully taken into account with the error modeling that we've negotiated with the Horizons people, accepted by the Minor Planet Center. The uncertainty is different in the along path and across path directions. Across path, the uncertainty is, we have set it about 80% of the asteroid's diameter, with reporting the position of the asteroid based on the chord going through the center of the asteroid, because we don't know which side of the asteroid the star path goes. And even on that issue, I've had discussions with the Horizons people for asteroids where we're fairly confident that the position of the asteroid, such as Ceres, large asteroid, we have a single chord observation of that. The Horizons people are adamant that the positioning of the asteroid must not take into account the ephemeris of the asteroid. It's got to be totally independent observation. So they do not want us to place the asteroid on one side or other of the occultation path. There's a raft of issues in there. If I can focus on some other issues, on the noise issue, there's a whole source of different, whole different set of noises. And when you're dealing with something faint, the best way to deal with noise is to use an integrating camera, because with that, you're smoothing out, well, you get rid of the amplifier noise in the output of the camera, which is a significant component of the noise generally. With an integrating camera, if you integrate, say, 32 frames, you have 32 frames worth of noise coming from the sky background, but from the reading of the CCD chip and outputting the signal out of the camera, you only have 1 frame's worth of noise, not 32 frames worth of noise. So dealing with noise for faint objects, I would strongly urge the use of an integrating camera.
Like
The other interesting, yeah, it makes a huge difference. The other interesting thing with noise, and I'll be mentioning it briefly tomorrow with my talk about 5 issues to think about, but I'm probably going to preempt what I'm saying there tomorrow. For faint signals, there's a very strong argument to not do any background subtraction. Reason why? In your case here,
and I did not.
The dominant source of noise is the background. When you do a background subtraction, you've got 2 components to deal with. You've got the inherent noise in the star, and you've got the noise in the background. Now, whenever you add or subtract 2 signals, the noise is always added. So when you do a background subtraction on this type of image, you in fact increase the noise in the signal.
Right. Thank you for helping me with the ARITA occultation a month or so ago, and we both kind of, I think we learned something there.
Yeah. There's a whole heap of issues. The final comment I'd make from my perception of it over the years, the videos I've seen which have caused the most angst is those. I wouldn't say that, Richard. But when the star is barely visible, they're the ones that create the biggest problems. And certainly when you come into the issue of certainty, it's a real problem. And last week I've been dealing with a video taken in Europe, where the observer was absolutely adamant that he had an event, and in the process discovered a double star. And to achieve that, the first run through Tangra, nothing there, but then he went through the process of amplifying and stretching and all sorts of things that you can do in Tangra. And he is strongly of the view that he had found not only a single occultation, but a double occultation, a double star and so forth. And all he'd done was amplify the noise. I can't emphasize, from my perspective, I discourage people from having events which are so close to the being visible, because there are so many problems with getting reliable results from it. It's natural for us to want to say, yeah, I can do this stuff. But to me, the challenges are really, really serious. Yeah, that's probably enough to say, Rick. And I look forward to your next faint and obscure occultation light curve.
Well, just to say, so tonight there is a 14.2 star I'm going to try, but it's almost 7 seconds long. So I'm hoping that I can, that's enough points that it'll pop out of the noise. We'll see.
I'd like to agree with Dave Harold that on a couple of points, it is important to have a sufficient signal to noise ratio that you can be sure about your result. And we should be planning our events accordingly. That is, if we're going to get a super low signal to noise ratio, we could say, well, that's going to be a no observation, even if I record the star. So, you can plan on this and avoid a lot of frustration. The other thing I want to reiterate that Dave pointed out is that anytime you do an operation such as calibration of a video or picture for that matter, you increase what I think of as entropic noise, that it's related to entropy, it's random noise. You can decrease the interpixel variation by calibrating it, but that is not the noise you're worried about. The noise you're worried about is the entropic noise, the truly random noise that's not related to the location on the image. And that noise always increases with any operation you do. And it increases, basically the noises are independent of one another, and therefore the noise increases as the quadratic sum of the original noises. So it's very, particularly with a faint event, you want to avoid doing those operations. But at the same time, I want to point out that there is a role for integrating your video. And basically what Rick is describing is a type of integration that we haven't used. And he has asserted that it's helpful, and it was helpful to him in analyzing this case. And I think that, sometime Bob Anderson and Rick might continue to have a long discussion about this and decide whether this would be a useful adjunct to the PyMovie program. I think that's a reasonable possibility anyway. And I wanted to also mention that the program Registax has a easy to use modality to make integrated videos out of non-integrated videos, and thereby bring out the appearance of a faint star. And of course, it disrupts your timing because you're increasing the exposure duration when you do that. So, okay. Any other comments?
Can I just add to that, or the original question asked about capabilities in Tangra? Tangra does have the capability for what it calls pre-processing, where it will undertake an adding together of the images before it does the measurement. So that has the advantage of reducing the noise in the background. But it also has other tools in there of adjusting the vertical scale, it's image stretching and so forth. We rarely use those things because it's the risk of getting false results out of it, or being deluded into having a you've got a good result when there's really little justification. It's just not worth it. The things that are useful in there is you can display the noise and signal minus noise or signal alone, and various tools in there which they're worthwhile being aware of. Yeah, I'll leave it at that.
Is there flat fielding in Tangra?
To be honest, I can't tell you directly. I know Tangra, Bristow does have it's set up to do proper photometry, and that does have flat fielding. So it's something to be, put it on your computer. It's a simple download, and there's no formal installation as long as you're using Windows. You just unzip it into a folder and put a shortcut to it, and that's all you got to do.
Okay.
And you can do spectroscopy with it too, I think.
I'd like to move on if we can now. Thank you, Richard, Rick, rather. That's an interesting subject to discuss, and I hope you have some fruitful discussions with Bob Anderson about that.
Sure.
Tony, will you be